Welcome to the Connect with BMC Helix ITSM and Remedy webinar. During today's session, you're able to ask questions of our panelists. The questions and this webinar recording will be published to our YouTube channel and communities a week from today's broadcast. Today's topic is leveraging the new Java AR log analyzer, and Doug Reif will take us through this content. Over to you, Doug.
Thank you, Greg, and welcome everybody to today's webinar. My name is Doug Reif. I'm a Principal Technical Support Analyst at BMC Software, and today I'm going to be talking to you about leveraging the new Java AR log analyzer. The agenda for today will be to do a brief overview of the log analyzer. I'll show you some of the key features. We'll talk about how to install and how to run it, and then we'll look at the results. I'll show you how to view the results, and then I'll show you how to make the most use out of the analysis provided by the tool. Then we'll follow up the presentation with some references so you can do some research on your own after the webinar. The AR Log Analyzer is a tool that makes sense of your ARSystem logs. If you've ever analyzed these logs yourself, you know that it can be quite difficult to get a whole lot of value out of them on your own. So the Log Analyzer consumes your ARSystem logs. It merges your log history files, all of your .1, .2, etc. files. It can handle different log types such as filter, API, SQL, and escalation, and then it aligns all those logs based on the thread ID and the timestamp. And once it's done analyzing them, it generates very useful analysis that can either be text or web-based. It generates several reports that are used for analyzing performance issues. So you can use those to identify root cause for performance issues, and you can also proactively monitor your performance by using these reports. You may have heard of or even used some version of AR Log Analyzer in the past. The tool has been around since the early 2000s. All but the current version have been written in PERL. So this current version changes that, and we now have it written in Java. The earlier versions required two separate utilities. One utility combined the logs and cleaned them up, and the second utility did all the analysis and generated the reports. In the past, we really only introduced minor features and bug fixes just to slightly improve the product and keep up with the logging changes over the years. Finally, in 1908, with the addition of the trace ID, the old log analyzer just simply couldn't parse the logs anymore. So that's why we have AR Log Analyzer 3.0. This new version is Java-based. It works on any current version of Java, which makes it easier to execute and maintain. And we took the opportunity to add significant functionality. Now, this new Log Analyzer 3.0 will support logs from all currently supported versions of ARSystem. It's designed to work with logs all the way back to ARSystem 9.0, but it's likely to work with logs that are even older than that. Now I want to quickly announce that starting today, version 3.1 of the AR Log Analyzer is available. So all the new features that I'm going to be showing you today are all included in this new version 3.1. And when I give you the link to download it, it will now be available for you to download. Now let's look at some of the features of AR Log Analyzer. First of all, it's very easy to launch. It's a single Java command to merge and generate the report, and you can drag and drop in Windows. You can simply drag a log file or drag a folder of log files onto the utility to have them processed. Once the tool is done processing your logs, it'll give you some general log statistics that might be useful, such as the thread counts for each type of thread that showed up in the logs. Plus, it'll show you the total number of users that appeared in the log, as well as the total number of APIs and forms and other information. And the real value of this tool is the detailed analysis that it will provide in the API, SQL, filter, and escalation reports. These contain a lot of really useful information that you can use to dig into any problems or performance monitoring that you're trying to do. It also provides drill down, so if you find data that you want to look into, such as a long-running API call, you can simply click on that API call and it will drill down right into the log so you can see what happened during that API call, such as a SQL that ran as a result, or filters or other activities that ran as a result of that API being called. So the drill down really helps analyze your logs. Lastly, one of the things we added to this tool was to be localized. It handles localized timestamps and makes sure that it sorts and filters correctly based on whatever the locale of the timestamps were. Plus, it also has to make use of messages that are localized if you are running a localized AR server, and it handles all that automatically. Now let's look at how to obtain and install the utility. The utility was announced on the BMC communities in a blog entitled BMC Introduces AR Log Analyzer version 3.0. So you might want to look up that article and read it. And that article points to a knowledge article 373578 that includes the detailed instructions as well as a attachment that includes the utility itself. In installation, really it comes down to one simple step, which is unzip the file that you got from the knowledge article. You can unzip it wherever you want, although it's nice to unzip it into a directory that's easy to remember the name or identify later on when you're calling the utility. You can optionally add that directory to your path. Of course, that'll make it easier to call on later when you're trying to run it. That is optional, but it is assumed that your Java directory will be in your path statement. Once you unzip the utility, you'll notice that there's 9 pairs of batch and shell scripts that are included. These are all examples and can be used right out of the box as is. And you can see by the names of these batch files and shell scripts that each of them uses a different set of options. For example, the first one, analyze single file web zip.bat, analyzes a single file that you provide as input. It will create web output as opposed to text output, and it will create a zip file of the analysis once you're done. So there's several different features that are used here. Now you may want to opt to analyze an entire folder, so you may use one of the analyze folder batch files. So you could potentially run analyze folder web zip so that it will analyze the entire folder, create web output, and then zip the contents up once you're done. Depending on how you run the utility, you're either going to get text output or web output. If you decide to use text output, you're going to end up with a file called the file or folder name that you provided as input .arloganalyzer.log. For example, if you ran it against a file called log files or a folder called log files, you'll end up with a single file called logfiles.arloganalyzer.log, and you can simply open that with a text editor. If you chose to use the web output, then you're going to end up with a new folder that's going to be called the folder or file name that you passed in to be processed .arloganalyzer. So you'll end up, for example, with a folder called logfiles.arloganalyzer. And in that folder, there'll be a file called index.html. And that file you will open up with the browser, and then you'll be able to see all the reports and everything, all the output generated by the utility. Both the web and the text file contain all the same reports. They're just formatted differently, obviously. And then the web, which is HTML, also provides drill down so that within the reports, you can find a line number that you want to look into more and you can drill down into it. So next we'll show some examples of all this. So now I'd like to spend several minutes doing some demos for you. Let me pop onto my test box here. Okay, on my test box, I've taken the zip file that came in the knowledge article that has the log analyzer in it, and I simply unzipped it into a folder called AR Log Analyzer. And you can see once I unzipped it, I get a bunch of batch files and shell scripts. So these I can either run manually, just go to a command prompt and run the batch file, or I can use them to drag and drop if I'm in Windows. So over here, you can see I have an AR Logs 1 folder. It's got a bunch of API filter SQL logs that are .log.star, so some number. And this is a fairly typical set of logs you might see. So what I want to do is analyze this whole folder. When I look at the batch files, I see there's a bunch of batch files that say analyze folder. That's one of the things I want to do. The next parameter says logs file. Some of them don't say logs files. So I want to analyze star.log, so I'll pick one of those. And then I want to get web output, and I'd like to zip the contents. So this one here ought to do all of that. So I'll simply drag my folder onto that batch file. And as it starts up, you can see from the top it says it's going to take an input parameter of the folder name, and then we'll analyze all the star.log star files, and it'll create web output and zip the contents. That's exactly what I wanted it to do. Another thing you can see is it showed that there's 2.44 gigabytes in files that it's going to be processing, and that it has allocated 20.5 gigabytes. Now the default setting for the XMX parameter in the batch file is 20 gigs. If you don't have 20 gigs available, it will start paging to disk when it needs to, so it'll automatically handle the paging. That'll slow it down. If you do have more memory on your box, you can simply edit the batch file, change the -xmx parameter and give it more memory. So maybe it could do the entire processing just in RAM without ever paging. Now this is going to take several minutes to run. So what I'll do is I'll stop looking at this and I'll show you what it looks like after it's complete. Once the batch file is done running using drag and drop, the command prompt will just disappear. So I took a screenshot of what it looked like just so you could see. So it read in all the logs, then it started processing the transactions, it started creating the web log files because I chose web output. Then you can see it's processing the API, SQL, and filters. Then it's generating the remaining web pages, and it tells you it took 15 minutes and 52 seconds to process 2.44 gigs, which is pretty good considering it was filter API and SQL logs, and there was quite a bit of them. And the last thing it does is it zips the output. So you can see all that there. If you have a huge set of logs, just wanted to show you this is the kind of output that you're going to be watching for to see that it's progressing along. Once it's done, you're going to end up with a folder that's the original folder name, ARLogs1 space analysis. So in that folder is where my analysis is. It also, because I chose zip, it also zipped up that folder and it created a 184 megabyte file in this case that's a zip file. And that's the file that I could either transfer to another system or I could transfer it to support to work on. Now before I start looking at the logs, I want to show you a couple other things. Let me show you just what if I wanted to analyze a single file. This will be really quick. So I could take one of the files here and just drag it onto one of the batch files. And you can see that there's batch files that say analyze single file web zip. So that looks like what I want. I'll just drag it there. It'll process that single file. It should be relatively quick. It also tells you, I want to point out what language it found. So the timestamps might be localized, and also some of the messages might be localized. And this tool will automatically try to detect what language it is and what the time format is and handle it correctly. So I'll let this run, and then I'll show you what the output looks like. Again, when using the drag and drop, as soon as it's done, the command prompt is just going to disappear. But once it disappeared, what I see over here is that it created a folder using the file name that I dragged and dropped, which is that .log.1 file, and it adds analysis at the end. That's the folder that it created. So in that folder is going to be my analysis. It also created a zip file with the same name. So that's my output. One last thing I want to show you is how would I run this on a Unix box. So let me pop over to a Unix box and I'll show you that. Okay, I'm going to connect to a Unix box now. The first thing I did was I used an FTP program to go into the op directory, and I created AR log analyzer directory and extracted the zip from the knowledge article. So this is the installation on a Unix box, is just to extract it into a folder. Now I also have a directory here that has some logs in it. So this folder has a bunch of logs. It's still the same format, log.somenumber. Now this is what I want to run the log analyzer against, is these log files. So now I'll pop out to a terminal session. And the first thing I did was change directories to the directory that contains my directory with the log files in it. So in my logs folder here, I had a folder called escalation test. And that's what I want to process, is escalation test. I might have forgotten the names of all the shell scripts, so I just did an ls on the AR log analyzer directory for the .sh files. And you can see here's the list of all of them. And probably in this case, I'll want to do something similar to what I did on Windows, which is analyze folder log files, web, and zip. So one of the reasons I might want to do the zip on a Unix box is just to view the files. It might be easier for me to send the zip over to a Windows box and extract it and open up with a browser. So I'm going to execute this command against my escalation test folder. And just run that. And you'll see I get similar output as it did on Windows, and this is going to take a couple minutes. So what I'll do is exit here, and I'll show you what it looks like when I'm done. While that's running, let me just take a minute to show you what these bash and shell scripts look like. There's not a lot of magic to them, so I popped back over here to my Windows box just so I could show you in a nice editor. Let me look at the one that I ran, analyze folder logs, files, web zip.bat. So that sounds pretty complex. When I open it, really there's one command that runs. It's a Java command. Here's the XMX parameter that you can change if you have more memory. You need the garbage collection parameter here. It just helps speed it up. And then the location of the jar file that it's going to run. So all that's pretty normal. And really the only parameters that are added in this one is the -z to zip the contents, -w to tell it that it's going to have web output, and then it names the web output whatever the value was that you passed into it, the thing that you dragged and dropped if you use drag and drop, and it adds the word analysis on the end. And then the last thing is the input. And here the input is star.log star. So very simple command line, and you can tailor this, create your own batch files. So we just provided some batch files to get you started, but feel free to come in here, create your own, edit these, and tailor them to your needs. Let's go back and look at the Unix box and see how it's doing. So it's finished. It took 5 minutes to run. It zipped the output. If I go back to my FTP editor here, I can look at this folder here, refresh it, and it has created an escalation test analysis directory, which will have all the analysis, and it contains a zip of that. So that's what I was expecting. So that's how you run it. From Windows, you can run it from the command prompt as well. I showed you drag and drop, but you can easily run it, the batch file directly from the command prompt. You can do that as well. What you would do is simply go to a command prompt into the folder that contains your log. So actually I want to be up one directory. And then from here, what I can do is just run the batch file from wherever it's located. It's located in C Log Analyzer. And then I'll put the name of the batch file I want to run, which in this case will be this one again. And then I'll include the folder name, which was AR logs 1. So I'm not going to run it because I already have analysis there, but that's all I would have to do is just execute that batch file and pass in the folder name, and if I want, I can pass in the file name. So that's how you run it on both environments. Now let's take a look at what the output looks like. So I'm going to navigate into the analysis folder that was created, and then I'm going to look for index.html and just open that with the browser. It opens up into the main intro screen, which is the general statistics. And you can see here it has a lot of really good overall information, such as the very beginning and start time of all your logs and the very end time of all your logs. The total elapsed time, which you can see here, was 2 hours. The total number of lines, and then the count of the API SQL escalations. In this case, there was no escalation logs. We'll look at some of those later. Gives you the total number of forms that were accessed in all these logs, the total number of tables accessed, as well as the counts of the different types of threads. And it shows here every type of thread that was logged in your logs. So like, for example, a private thread for 390.680 was logged, and there was 2 different threads that were run against that queue. So a lot of good information in that top table. The second table is the logging activity, and this shows you for each type of log that was contained in the entire log set, which happened to be API, filter, and SQL. This is the duration for each of those. The last section is something that you might use when you're doing the further analysis, which is all the input file names. So you can see here, these are a list of all 20 files that were read in. It shows the file's start and end time for each one and the duration for each log, and then it numbers them. So this file number will be used later. So you might find that there's, say, a long-running API call, and it happened to be logged in log file 7. So that might become useful later because you know exactly which log file contained it. So that's enough for the general statistics. Let's start looking at the rest of these. I'm not going to take time to go through every single one of these options, but I'll try to hit all the key features and most of the new features that are included in version 3. So the first thing let's look at real quickly is plain text. Now this is just a copy of the plain text output that you would have gotten if you had just run it in plain text mode. So by looking at this, you can kind of see what you'd get if you ran it in plain text mode. You'll see the 50 longest line gaps, and then you'll see the 50 longest thread gaps, which are the two bottom options in the web output, then you'll see the API aggregates, including the 50 longest APIs, and then you just go on and all the items that'll be in the text report are the same items that show up on the web report. Next thing is the user guide. I just wanted to point out that there is a complete user guide. It talks about all the different options that you have. So I pointed out earlier that you had the -Z option and the -W option, and of course those are documented here. So use this guide to figure out if you want to tailor the batch files or the script files, then just use the instruction manual to get to know what all the different command line options are. So the next thing, and one good place to start when you're troubleshooting an issue, is the top 50 API aggregate. So the top 50 is going to show you the top worst 50 API calls, or when I say worst, the longest. So you can see this one took 4 minutes and 30 seconds to run. And you'll get the times of all the top 50. And you can see this is pretty bad. You have a bunch of API calls that are taking more than 40 seconds. So this is obviously something that you might want to look at and troubleshoot. So I mentioned that one of the cool features is the drill down. So on this first item here, if I want, I can click on this first line number. It's the first line number for the API call. The last line number is the end of the API call. The file number, remember I talked about in the general statistics that each file that gets read in gets a file number. So this file number, you can reference back to that and figure out exactly which file contains this. So I'll go ahead and click on one of the lines here. And so this was a service entry on the CHG infrastructure change, and a lot of stuff happened. And all the stuff that's in here is all for just the one thread that this ran on. And if I work my way through, I can see exactly what went on during that API call. And hopefully I can look at the timestamps and find exactly which action took the most amount of time and caused the API call to take 4 minutes. If I look real quick, I can see here right at 10:28 that the very next thing that happened was at 10:30. So it looks like there was almost 2.5 minutes that was absorbed in this one query here. So I'm not at this point going to try to figure out why that query took so long, but this is going to be a database tuning effort now. And at least I figured out what it is, and now I can troubleshoot why that query took so long. Maybe it needs an index. Maybe it's just a poorly formatted query where maybe it's doing leading wildcards and can't use an index, something like that. But that's what that top 50 will tell you. It'll tell you the top API calls, and then you can drill into it and figure out what went wrong. The next item is the top queued. Now this is kind of important when you're trying to figure out if you have enough threads. If you don't have enough threads, then work is going to queue. And the fact that I see here that some activities have queued means that at that point in time, there weren't enough threads. Now that doesn't mean that you need to go out and add additional threads because these numbers are pretty small. But it does, if you see large numbers here, it may be something that you want to look into and drill in further. You also have these group by form, group by client, group by client IP. One of the nice features is, and this is a new feature, is to group by client. So I could look at all the different clients, and you may know that Palm Pilot actually means Smart IT. So when I see Palm Pilot here, that means that all these activities were from the Smart IT client. And if I look at these, I can take a look at the total number on the right-hand side. I see that mid-tier consumed a total of 1 hour and 35 minutes of API activity across all the threads. And I can compare that to other activities. I can see that Palm Pilot, in that same amount of time, took almost 7 hours of work. So this is clearly a system where Smart IT is being used more than mid-tier. But what I may see is some integration client or some other client that took up all the time. In this particular case here, it looks like the client that took the most time is Smart IT, and so that might be an area of focus. Also have group by user, group by queue. So all the different queues, fast lists, and the different private queues are shown up here. So I can see maybe I have a private server that's doing something very specific, and I can focus on that. We also have thread statistics. Thread statistics show, this is a new feature. We had thread statistics in older versions, but didn't have this amount of detail. you'll see for every single thread, and these are sorted by the thread type or the queue, I get a bunch of information including the total count of APIs. So we'll look at this first fast one, had 2,800 API calls. 28 of those calls queued up. So that may not be too bad. The total queue time of those 28 calls was 4.4 seconds. And the total amount of time that was consumed on that thread during the log was 8 minutes and 32 seconds. So out of 8 minutes and 32 seconds, only 4.4 seconds was queuing. So this is good information. In this particular case, it doesn't look like I have a real bad problem queuing, although this might be something that's an indicator that I'm beginning to start queuing. So when I talk about proactively monitoring your system, this is something that you might proactively monitor and come back in a week or so and see if these numbers are worse, or in a couple weeks. Just keep an eye on them. It may indicate that what you do need to do is add a couple threads. In this case, adding a couple fast threads maybe. The next section is the SQL aggregates. And the SQL aggregates are much like the API aggregates. You have the top 50. So this will show you the worst or the longest SQL calls that ran and how long. So this one took 6 minutes and 55 seconds to run, which is pretty bad. And that might be a SQL that needs to be tuned. Maybe I need to create an index or figure out why a user or whichever client caused this query took so long to run. We also have group by table, group by user, group by queue, like we did with the API calls. The next section, and this is a new section and a great new feature, is the filter statistics. So now Log Analyzer can look at your filters, and this tells me, in this case, that I had a single filter that took 4 minutes and 29 seconds to run. So I can drill down in there and figure out which, I know the name of the filter, but I could figure out what it was doing. Maybe the second set fields action took a long time or whatever. So that really helps. I also have some more filter information, like the most executed filters. This kind of helps when you're tuning an overall environment where you want to look at, perhaps I'll have some custom filters that are taking a lot longer, perhaps looping, or they're running quite often, and maybe there's something I can do about that. Next, we have the most per transaction, and what this is out of all the transactions that are included in your logs, which transactions had the most filters fire within them. So we can see here, for example, a transaction on the CHG infrastructure change form ran 6,480 filters. Now, one downside of running lots and lots of filters is that they do consume CPU. And so on the far right-hand side, we have a counter for the filters per second, and you can kind of gauge that to relate to CPU usage. If you are running into some CPU usage issues, you can come back here and look and see maybe you have a huge number of filters firing on a transaction, and that might be affecting the CPU usage. So the next item is the most executed per transaction. And so looking at each individual transaction, which specific filter ran the most? So an example here, we see the NTE NTS filter ran 57 times within a single transaction. That same filter ran 49 times in another transaction. So this kind of gives you just another way to look at your filter usage. And if you're troubleshooting performance issues, especially related to set entries and create entries, and sometimes service entries, this might help understand how the filters running are affecting your performance. The last report we have for filters is the most levels per transaction. And this is often used to look at filter looping or filter recursion. In a typical ITSM environment, you may expect to see up to 5, 6, or even 7 filter levels. And that's all because you had a filter that did a push fields to a form, that's one level, and a filter on that secondary form pushed yet again to another form, that's the next level. And if that happens each time the filter level increases, if it keeps happening, what you may end up finding is that at a certain point, a filter on one form did a push fields back to one of the prior forms, and it causes a loop or a recursion condition. The last set of reports we want to look at in this report is the gap analysis. Now I am going to show you on another report, there is one more section for escalations. This particular log set didn't have any escalations running, and so I'm going to pull up another log set in just a minute. But first, let me show you the gap analysis. The first item is the top 50 line gaps. What this means is out of the raw logs, there were some times when nothing at all was written And that means across any thread, any queue, nothing was written. And quite often that means that maybe the JVM was actually hung. So if you look in this example, I have a lot of 9-second gaps where absolutely nothing was written. Now, if this was a relatively quiet environment and really nothing was going on, 9 seconds might be normal. But in a relatively busy environment, and this one does look relatively busy, these 9-second gaps might mean that I have too much garbage collection going on, out of heap, and so I'm constantly having to reclaim memory, something like that. So this is just an indication of something going on. But the fact that you have these gaps of times that nothing is running probably means that you have gaps in times that there wasn't any activity occurring, and the appearance to the end users is that you have a hung server. Now, for 9 seconds, it may not be long enough for anybody to have said anything. It may just thought that they had a slow response. So this is another way to look at, maybe you have slow response, but there's a very specific reason why. And the last one here is the thread gaps. Now, thread gaps show you whenever there was a line that had a gap in front of it, there was a space of time in front of this line that's kind of unexpected. And sometimes it just means that you're actually waiting on something that wasn't logged. There's some cases when you have plugins involved and the plugins themselves don't log anything in the SQL API and filter logs. And so there might be some activity that's going on, it simply isn't logged. Other times, like in the case that I'm looking at here, I see a bunch of user cache and I see bad password. So probably what's happening in this specific case is that somebody's logging in. They're probably using area LDAP or something, and so they're doing some sort of external authentication that isn't logged. And so there's a gap of time in front of this line here where all the external authentication was occurring. It might have taken, in this case, 45 seconds to occur. And then after that login attempt apparently failed, then we update user cache and we increment the bad password. So you can kind of infer from the log what happened here, but the reality was there was a 45-second gap where nothing was logged. Okay, now let me open up the analysis from a server that did have escalations running, and you'll see here that there's a section called escalation aggregates. And this has a lot of new stuff in it too. So in the past, we did have some escalation analysis. You'll find that in this new version, the escalation analysis is much deeper. So first we'll look at the top 50. This just shows the runtime for your escalations, how long they ran. So here I had some that were taking 6 and 5.5 minutes. So relatively what you expect to see here. The next section is delayed. So this is interesting. Sometimes an escalation won't fire because there was an escalation in front of it that didn't complete firing in time. And so this will help you determine if you have escalations that just are not getting fired in time. So the delay column here shows you how long the delay was. So I have some escalations here that waited for over 6 minutes to be able to run. This also shows you the escalation that was in front of it. And likely this escalation that was in front of it took a little too long, and that's what caused the escalation in question to run delayed. So what you can see here that a lot of these on the top are all running from pool 1. It's a possibility that in order to get some of the escalations that need to run on time to not be delayed, I'm going to have to put them on another pool. So it's really good information. The next one is the escalations grouped by form. So you can see for every form, the escalations that are running on it, and then all the statistics, how many times they ran, the min, max time, and all that. The next one is grouped by pool. So you can see here for pool 1, I have a lot of escalations running in pool 1. And I can see how many times those escalations ran and other statistical information. I can look down and I can see from here all the pools that were logged. So there was a handful of pools that were logged, and some of these only had 1 or 2 escalations running in it. So here's an opportunity, apparently from the logs I'm seeing here, is I do have some delays. Perhaps I could move some of these escalations onto another pool that's not very busy. So that's really good information that you get from the escalation aggregates. And that's about it for all of the new features and the common and the key features. Okay, I'm going to pop back to my slide deck here and talk about troubleshooting guides for a minute. So you may be aware that BMC has been spending a lot of time trying to create really good troubleshooting guides. These guides are based on commonly raised support issues that we're seeing, and so we're trying to help customers solve their own issues by creating these guides. And you can see the troubleshooting guide. I'm looking at just the ARSystem page here. The troubleshooting guide is easily found on the navigation bar under troubleshooting. And then under troubleshooting, there's a section for performance issues. And within the performance issues, there's a section on using the AR log analyzer to do your troubleshooting. So this is a really good guide to, now that you've seen the tool, how might you use it in a normal troubleshooting session? And so we can look at the guide a little bit. When you open up the troubleshooting guide for AR log analyzer, it shows the following information. The type of problem you're trying to resolve is just a general performance issue in the Remedy AR system. The symptoms might be slow performance, slowness or timeouts while trying to load a form, such as the overview console, any other console as well, just trying to load the form, slowness or timeouts while trying to create or modify a record, timeout errors that are logged in the AR error log. Those kind of things you might be able to solve by using the AR log analyzer, or at least you might be able to define the problem better and most likely be able to create a better support ticket if you end up doing that. So the solution for those types of problem is to use the information that's in the troubleshooting guide to perform the troubleshooting steps and possibly solve your own issue or create a BMC support case. The steps that are outlined in the document are to download and install the log analyzer, which we've shown you already. You need to enable a SQL API and filter logs. Now, if you're troubleshooting an escalation issue, then you want to enable the escalation log as well. And then you want to reproduce the problem while the logging is turned on. Once you've reproduced the problem, you can collect the logs and then run the log analyzer against those logs. And then you want to view the log analyzer output that I just showed you and try to make some sense of it. So some of the important things that you want to look at are the general statistics. It might tell you information about the threads, and it also helps you make sure that your logs are from the right time frame and that you have the right logs. And then really we'll start with the API aggregates and look for the longest APIs. You'll also want to look at the top queued in. Remember I showed you that can help you identify if perhaps you don't have enough threads configured. You can also look at exceptions. That's one area that I didn't really show in the demo, but exceptions will tell you if maybe you had an API call that started in the time of the log but never ended. So maybe the API took so long that even after you had turned the logs off, that API had not completed yet. And that's something that you'll look at in the exceptions. And the next thing you'll look at is the SQL aggregates and look for the top SQL and see if you can identify a specific SQL statement that might be causing the problem. Once you've done all that, perhaps you have enough information to solve the issue on your own. And if not, you can take that zip file that the log analyzer created and open up a support case and provide that and provide any other information that you found while you were doing your own analysis with the log analyzer. So let me walk through an example of doing just this. Okay, I pop back to my test machine here, and I'm going to open up a browser and point to a test form that I've set up here just for doing this simple test. Now this is really going to be a basic test, but hopefully it's instructional on the steps that you would take for any kind of performance issue you might have. Let's say an end user was complaining of a performance issue and you wanted to analyze it. So first of all, you try to reproduce the issue to make sure you can see it happening. So I'm just going to pick a status here, pending, and do a query. And from an end user perspective, this is simply taking longer than I expected to take. It might take, maybe I expected it to take 3 seconds and it took 5 seconds. Well, whatever it is, if the end user isn't happy, it might be something that we can look at. It is important to set expectations for end users because there are some queries that just are pulling back a lot of data and they're going to take a little bit of time. So that's one of the solutions, is not just maybe creating an index or solving the problem, but is setting expectations. So in this case, you can see it took several seconds to return the data. It was a fairly simple query, but I may want to find out underneath what's going on and have the log analyzer show me what's going on. So the first step after just verifying that I can see the problem is going to be to enable the SQL API filter logs. In this case, it was just a query, so there probably isn't any filter going on. Sometimes you'll have filters that run on get entry. So it's possible that you do have a filter going on. As soon as you do the query, the first record is going to be a get, and it's possible filters fired on that. So you don't simply eliminate filter logging just because it was a query. So I'm going to go ahead and turn off and then make sure I understand the names. And I can have all these point to the same file or different files. In the test case I'm doing now, it really doesn't matter. So I'm going to, just to make it easy to identify it, I'm going to put a 1 on the end of these and go ahead and enable the logs and then reproduce the problem. So now that logs are enabled, I'm going to go back to my test. I'm going to do a new search and try the same thing again. Sometimes the end user will simply get a timeout message like an AR 94. And if it's an AR 94, what it means is the client timed out, but it's possible that ARSystem is still waiting for the query to return. In cases like that, you might want to leave the logging on a little bit longer, maybe even 5 to 10 minutes longer, so that you can try to capture when AR server stopped waiting for the database, or maybe the results finally came just much later. So think about that and keep the logging on a little bit longer. For the test I'm doing now, because I didn't get a timeout, I know that whatever I wanted to log is now done logging. So I'm going to disable the logs. And now what I want to do is collect my logs and run Log Analyzer against those. So I'll prepare those now and start the log analysis. So I took the 3 logs, the API SQL filter logs, and I dropped them into this folder called ARLogs2. And now, as you recall, I can simply drag and drop my ARLogs2 folder onto the batch file that I want to run with, which will be this one right here, that will recreate the web output and the zip output. Now this should be pretty fast. It's already done. So now I can open up my ARLogs2 analysis folder, open up the index.html, and start looking. And if I look at the top 50 API calls, I see an API call that took 10 seconds, and it was a get list entry with fields, which is a query on exactly the form that I was working on. So this is showing you that right off the bat, the only long thing that happened on this server during this time was my query that took 10 seconds. Now, arguably, 10 seconds is not a long period of time, but depending on what the end user experiences, it may be a lot longer than they want to wait. So it's still worth looking into. But now let's drill down in and just see what else we can see here. So I'll click on the first line. It was line 251. So I come down here and look at line 251 is right here. You can see my GLEWF on that form. And let's just see what happens. We get a begin transaction. We get a select statement selecting a bunch of fields where this value is equal to 3. That was pretty quick. Then we see a select count, and that one actually took 10 seconds. So for some reason, the select count took 10 seconds, whereas the other select statement didn't. I don't know why that is, and I'm not going to troubleshoot that right now, but this is an example of perhaps an index on this field would have helped. It's also possible that that field isn't selective and an index may or may not help. But at least I can get right into the nuts and bolts of the problem and see exactly which SQL statement is the problem, and I might be able to take this to a DBA and say, hey, can you do something about that? So I might be able to solve this on my own. Now, maybe you have a trickier situation than this where it's not so cut and dry, and at this point you're looking at the top 50 APIs, and maybe 10 seconds isn't a long period of time, so you don't see anything really here. You can look at the top queued. In this case, there were no APIs queued on my server at all. I have plenty of threads, so nobody's ever waiting. I can look at some of the other statistics. One thing I mentioned is you can look at the exceptions. The exceptions will tell you if any API calls began within the logs but didn't end within the logs, or maybe they ended in the logs but they didn't begin in the time frame of the logs. And sometimes it helps with performance issues. If you have an API call that began but it never ended, it could be that that API has taken just a really long time. So the next thing we want to look at is probably the SQL statements, and we can click on the top 50, and we'll see right away there was a query that took 10 seconds, and that's going to be the select count that we already saw. So I mentioned that this was a really simple test case scenario, but I wanted to go over the steps of troubleshooting using Log Analyzer. So at this point, I think I've learned everything that I want to learn out of the log analysis for this simple test case. And if I can resolve it on my own or invoke the DBA to help, that's great. Otherwise, what I can do is take the zip file that was created from this, from the log analysis for AR logs number 2, create a support ticket, provide the log analysis zip file, and let the support person know the things that I've tried and what I gleaned from the log analysis, and then let support help me take it from there. And it should be a lot better support experience because you provided some very useful analysis with this AR log analyzer zip file. So let me pop back into the slide deck here. The last thing we want to show is some references so that you can go and do some more research on your own. So the first thing is there's a blog article that I wrote that introduces the new version 3 of the log analyzer, and it makes reference to the knowledge article, and that knowledge article actually contains the zip file with the utility in it. And the last link is the troubleshooting guide that contains the steps for using ARSystem Log Analyzer. So in summary, today we showed you the new AR Log Analyzer, which has been vastly improved. It's a lot easier to install. It's as simple, just extract it into a folder and it's installed. It's much easier to use, and you have the option of drag and drop. It's faster. The time to merge and create the reports is at least 3 or 4 times faster than the older versions. It's smarter. It creates more useful results that are going to provide you more information about troubleshooting your performance issues. And it enables self-solve for your own performance issues. So hopefully you can use this tool and solve more issues on your own faster. And don't forget to use the troubleshooting guide before you open a case. The troubleshooting guide for not just the performance issues, but for many other issues can help you self-solve and get your problem solved much faster. So thank you very much for attending this webinar today. Back to you, Greg.
Thank you. And now I'll take us through the self-help in contacting BMC. The YouTube channel where this webinar will be posted is listed here. It contains past webinars as well as a rich set of how-to videos. The Connect with BMC Helix ITSM and Remedy webinar schedule is available at this community's link. And the hot off the press newsletter for trending information is available at this community's post. As always, contacting technical support via web, phone, email, and these social channels is available. At this time, that will conclude this webinar. Thank you for attending.